Hi, this is Alex from devstories.eu. LiteLLM, the Universal LLM Gateway, Episode 3 of 24. Rating custom error handling logic for 15 different AI APIs is a great way to waste your weekend. Every API has its own unique way of telling you that you're sending too many requests or that your token is invalid. To stop you from writing endless conditionals, LiteLLM uses unified exception handling. Instead of learning how Anthropic, Cohere, or Google surface their errors, you only need to handle one standard. LiteLLM maps all underlying provider exceptions directly to standard OpenAI exception types. If a request fails, the gateway intercepts the raw error, translates it based on the HTTP status code and the provider response, and raises the corresponding OpenAI error. Consider a scenario where you use a Hugging Face inference endpoint. During peak hours, the endpoint gets overwhelmed with traffic. Hugging Face will reject the request. If you were calling their API directly, you would need to parse their specific HTTP 503 service unavailable error or a custom throttling message. With unified exception mapping, you do not need a specific Hugging Face exception handler. You structure your code using a standard try block around your generation call. Right below that, you add an accept block designed to catch an OpenAI rate limit error. Inside that block, you trigger your standard exponential backoff function. Your application pauses, waits, and retries the request. If you later swap out Hugging Face for Vertex AI, your backoff logic remains exactly the same. The OpenAI rate limit error catches the Vertex throttling event just as reliably. This mapping covers the entire standard set of failures. You can catch an OpenAI API timeout error when a remote server hangs. You can catch an authentication error when an API key rotates or expires. You can handle an API connection error for network drops or a bad request error if your payload is malformed. Your application code treats the whole AI ecosystem as if it is communicating solely with a single, predictable provider. Here is the key insight. Sometimes a clean abstraction hides too much context. A generic OpenAI bad request error tells you the call failed, but you often need to know exactly why. Azure, for instance, applies strict content policy filters. If Azure rejects a prompt because it violates safety guidelines, mapping that to a generic OpenAI error risks dropping the specific safety flag you need to log or show to the user. To solve this, LiteLLM attaches an attribute called provider-specific fields to the exception object. When you catch an OpenAI exception in your code, you can inspect this attribute. It contains a dictionary holding the original unmapped error data straight from the provider. You get the unified try and accept flow for routing and retries, but you keep the granular data for debugging and auditing. You build your resilient systems, your retries, and your circuit breakers entirely around the OpenAI exception classes. Standardizing your error boundaries prevents provider-specific failure modes from bleeding into your core application logic. Thanks for listening. Happy coding, everyone.